Aqueducts are essentially man-made streams that transport water from natural resources downhill to cities and towns. They must be constructed carefully so that the water does not run too fast, damaging the channel through erosion, or so that the water doesn't move too slow, allowing it to stagnate. The most famous feature of Roman aqueducts are their bridges, which are used to cross valleys and ridges. However, Roman engineers would also use inverted siphons dug into low areas to pressurize the water, pushing it through a low area without the need of a bridge. Modern aqueducts follow the same principles as ancient models, while using some modern advancements to allow them to go farther away and to clean the water. Modern aqueducts still use open-cut channels for water transport, but they also use pipelines in areas to avoid freezing, evaporation, and pollution. Water flows to treatment plants in modern aqueduct systems. The first known aqueducts were built in the second millennium in the Minoan civilization in Crete and in Mesopotamia. They were simple tunnels and channels dug into the existing landscape with the occasional clay tiles to reduce the absorption of water. Ancient civilizations throughout history, from Egypt to China, used some form of an aqueduct. The Romans are of course the most famous civilization to use these devices, making them grand structures. They used massive arched bridges to span large valleys, making them out of famous Roman concrete. Aqueducts are still used today on a truly industrial scale, feeding megacities like LA and New York City, spanning hundreds of miles. The main materials that have always been used to construct aqueducts are stone, concrete, and compressed soils and clays. Lead pipes were also used in systems like the Roman aqueducts. More modern aqueducts use similar materials while replacing dangerous materials like lead with steel, as well as making other improvements. As water becomes scarce in times of drought, the canals are being lined with polymers and impermeable soils to drastically reduce the amount of water lost to absorption. The concrete used in aqueducts has changed over time, with the Romans using their famous mixture of concrete. The composition of that was lost when the empire fell. As a result, new concrete mixtures have been invented and are what we see today. A significant advancement in concrete repair is also present in the form of carbon fiber. Engineers use carbon fiber as a lightweight alternative to repairing sections of damaged concrete. Possible improvements to the concrete used in aqueducts would be impermeable concrete, so as to simplify the construction process and eliminate extra linings. Carbon fiber can be found in cars, from wheels to chassis, tennis rackets, bathtubs, and helmets. Carbon fiber was invented in 1860 by Joseph Swan, who produced carbon fiber filaments for light bulbs. It wasn't until 1963, when the UK Ministry of Defence patented a new method of production, that the potential strength of carbon fiber was realized. It is not naturally occurring. Carbon fiber is produced through both chemical and mechanical processes. First, polymer strands are brought together into fibers, which are then heated in the absence of oxygen. This process, called carbonizing, expels most non-carbon elements from the fiber and leaves a tightly packed chain of carbon atoms. Carbon fiber is used everywhere in society, from the production of consumer goods to construction. One of the main functions of carbon fiber is making existing products lighter while maintaining or improving strength. This can be seen in things like cars, where according to the U.S. Department of Energy, the use of carbon fiber can reduce the weight of a car by 50%, increasing fuel economy by up to 35%. Carbon fiber has come a long way from being just a light filament. Carbon fiber can have a huge impact on the economy. By substituting materials like aluminum and steel, carbon fiber could eventually make many products easier to manufacture. This would allow for the production of high-quality items with incredible durability for the same or even lower cost of goods like bikes and bathtubs. This could lead to general increase in the standard of living. Carbon fiber could also push some materials out of the market, like harmful plastics that can't be recycled and expensive metals like titanium and aluminum. A weird characteristic of carbon fiber is that it is a great material for a huge variety of applications. It is chemically inert, making it perfect for use in nuclear reactors. It dampens vibrations very well, making it good for audio equipment. It is very light and strong, making it excellent for sporting equipment or cars. It is biologically inert and X-ray permeable, making it excellent for implants. It also has electromagnetic properties, making it useful in radiology equipment.